Welcome to Session 13, Surface Area and Nets. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to interpret a net as every outside face of a three-dimensional solid, fine box, cube, and cylinder surface area without including hidden interior regions, adjust a formula for open top or partially covered objects. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The cylinder unfolds into circular bases and a rectangular side. The volume and surface area measure different features of the same solid. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A closed 5 minus by 3 minus by 2 box has surface area 2, 15 plus 10 plus 6 equals 62 square units. If the 5 minus by 3 top is open, subtract 15, leaving 47 square units. Surface area counts only exposed covering. Nets make every face visible, while curved solids require separating flat bases from the curved lateral surface. Draw or imagine a cross-section and decide whether you are filling the solid or covering it. This separates cubic volume from square surface area. Now add a precision check. For a solid, mark the base and the perpendicular height, then separate flat faces from curved surfaces. Keep pi or other exact values through intermediate steps. If the object is open, attached, or partly hidden, count only the faces the context says are exposed or filled. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, list the exposed faces or surfaces before calculating any area. Second, pair congruent faces on a rectangular prism, top divided by bottom, front divided by back, and left divided by right. Third, calculate each face area, multiply by its count, and add the results. Finally, remove any face that is open, attached to another object, or explicitly not covered. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A cube has side length 6. What is its surface area? Step 1 is to organize the information. List the exposed faces or surfaces before calculating any area. Step 2 chooses and sets up the relationship. Pair congruent faces on a rectangular prism, top divided by bottom, front divided by back, and left divided by right. Step 3 carries out the mathematics. Cube surface area is 6 squared. 6 times 6 squared equals 216. A useful check is to surface area uses square units, not cubic units. The answer is 216 square units. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now is your turn. A box is 6 by 5 by 4. What is its surface area? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 148 square units. Surface area of a box is 2, LOW plus LH plus WH, 2, 30 plus 24 plus 20 equals 148. A useful check is to add the 3 different face areas, then double. Use this coaching check as well. Annotate the net with a check mark as each face is counted. This prevents missing a face or including one twice. Session recap. First, list the exposed faces or surfaces before calculating any area. Next, pair congruent faces on a rectangular prism, top divided by bottom, front divided by back, and left divided by right. Then calculate each face area, multiply by its count, and add the results. Finally, remove any face that is open, attached to another object, or explicitly not covered. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.